we will cover today. Addition. First of all, the names of an addition problem. I'm pretty sure you probably are pretty good at that. 6 plus 7 is 13. These two things here are called what? Did we do this already? I thought we did this. Maybe it was a different place. The two things that you add together are called, Lauren? Addends. And the thing that your answer is in math, rather than just calling it an answer, Aaron, we call it a sum. Math is something special, as we say in math world. No plain English there. Now, with that, and I don't know if we talked about this before, we have what's called the commutative property of addition. Does anybody know what that is? Did we talk about the commutative property? Based on the awkward silence, I'm going to say we probably haven't. Remember, I do this 4 times a day to 4 different classes, and sometimes we talk about them. When you were asked about the commutative property, and we probably should put this under the letter C, how would you know to look under addition if I asked you what the commutative property was? Would anybody know to look under addition? Probably not. So, you should probably take out a blank piece of paper and write commutative property on the top of a different piece of paper. And I only do that, I don't want to do it either, but I want to do it because I know that it will come up and you'll know. Commutative property. I hate to make you waste a whole other piece of paper, but there'll be no way you would know to look under addition if I asked you what the commutative property was. And it might come up. Does anybody know what that property says or is? Anybody know what the word commute means? If I asked you if your parents commute to work, does anybody know what that means? Maddie?
Talk.
No. Zach?
Travel.
Travel, or drive, or move would be the thing. When you think of that, think of the word commute and think about, you say travel, drive? I guess move would be the word that would. Because what the commutative property says is this. If you have 6 plus 7 plus 4 plus 3, and I asked you to do that problem, I'm sure you've been taught this before. What would be the easiest way for you to do this? Actually, you can't even do it in your head. No, I'm not a big do it in your head.
The numbers near each other.
Okay, but even still, if I did that, I'm with you there. 6, 7, 4, and 3. But still, to do that, I mean, I'm not a big fan of going 6 plus 7 plus 4 plus 3, but Lauren says,
You could do 6 plus 4 is 7, 7 plus 3.
okay, and that's what the commutative property allows you to do. Okay, the commutative property of addition allows you to move the numbers so that it makes it easier to add. In other words, I can take this 7, get rid of it, move the 4 there so I can do 6 plus 4 and get 10. And I can slide the 7 back in there and get 10. So it is 10 plus 10, which is 20. Okay, you are not allowed to do that with subtraction. Okay, you are not allowed to, if I had 10 plus 8 minus, no wait, I'm sorry. If I had 10 minus 2 plus 3, what's the answer to this? First of all, let's see what's 10 minus 2. And plus 3 is 11. But if the commutative property worked for subtraction, I could move these around and put the 3 here, or I could do this first. What is 2 plus 3? What's 10 minus 5? Does that give you 11? No, the commutative property does not work with subtraction. It only works with addition, and it will work with multiplication. But that's the property that allows you to move things around to make them easier to add. Okay? So whenever you're asked that, you're gonna say, oh, I know the commutative property. It really just says this, that 5 plus 4 is the same thing as 4 plus 5. You can flip-flop those things around and it doesn't change anything. There's the commutative property. Now, with that, unfortunately, we need to take out another blank piece of paper. And on top, write the identity property. And the identity property, I don't know if you're going to take a guess at this one, but if you have an identity property, an identity problem, what does that mean? Okay. Identity. Joseph? No, the identity has nothing to do with moving or changing anything. Identity, I should just tell you because there's no good way to say it here. The identity property just means this. I'll give you a couple examples. And it's basically math people making something really easy sound really hard. What do you suppose the identity property says? Yeah?
Adding 0.
Does what?
Doesn't change anything.
Exactly. You gotta hit it right on the nail, right on the head there. The identity property just says that adding 0 to anything gives you the same number. Now, if you know that, you don't have to write this down, but what do you think the identity, this is the identity property of addition. What do you think the identity property of multiplication is? Knowing that adding 0 gives you the same number, what do you think the identity property of multiplication is? Aaron?
If you multiply something by 0, it doesn't change.
It does change though if you multiply something by 0. 7 times 0 is 0.
If you multiply something by 0, then it stays 0.
It becomes 0. That's a 0 property. But remember, this one is this. We are looking for what, when you multiply it by, gives you the same number you started with. 0 always gives you 0, no matter what the number is. That's a 0 property of multiplication. What do you think the identity property of multiplication is? Zach?
You times by 1.
Exactly. Multiplying by 1 gives you the same number. You don't have to know that. I just wanted to throw that in the title. All right, you ready? Last piece of note paper. This one you really will learn something today.
Yes.
And you can use this with your parents and they'll think you're like Einstein. This is this, an algorithm. You remember not so long ago, Al Gore was the Vice President of the United States? This has nothing to do with Al Gore, but it is all about algorithms. What? Plus, it might be a good spelling word. An algorithm. Oh, look what time it is. Gee whiz.
Oh, wow. It's already 11:51. Yeah. It's 11:58 fasting.
Still 11:51. An algorithm, children, I'm not even going to ask you for this. Algorithm is just the way that you do something. The way you do something. And you can use this with your parents all you want. Here's an example. If I were not, this isn't about math, but if I asked you your algorithm for brushing your teeth, okay? For you to brush your teeth, what is your algorithm? Well, first of all, you probably, I don't know where you keep your toothpaste, but you probably maybe open the medicine cabinet. Then you maybe take the toothpaste tube and open it. Put your toothbrush in your other hand. Then what do? You squeeze. How big of a piece? How much toothpaste you put on the toothbrush? Hey, somebody said it, about a pea size, right? Who said that? Oh, was that you? Yeah. You squeeze about a pea size. They tell you on the directions. It's almost like the directions. Pea size amount on brush, and so on and so on and so on. And you'd have to go into this, and then you'd have to open your mouth. You'd have to take the toothbrush, and you're supposed to go around in circles, right, or whatever, back and forth, inside, outside, brush for how many seconds? You're supposed to sing the alphabet song like a dozen times. 2 minutes. I think it is 2 minutes, isn't it? Blah, blah, blah. That is the algorithm for brushing your teeth. And we have algorithms that you do all the time. You just don't call them algorithms. What do we do? What's our algorithm? Let's say you're adding, 462 plus 58. 462 plus 58. What would be your algorithm for doing that? Well, probably the first thing you do is write it up and down, correct? You really want to, because it gets a little harder if you try to do it side by side. So step number 1 in your algorithm is 462 plus 58. Okay. Now, if you gave this to someone that didn't know how to do math, what would be the next step that you would tell them? Because they would just look at it and go, well, it looks like it's 4, 11, 10. There's my answer. It's 41,110. Which you know is not right because I didn't follow the right algorithm. What algorithm do you use when you do that addition problem? First thing you do is what? Sophia? Okay, add the ones column together. And you get 10, but do you write 10 down there? What's the algorithm to say? Sophia, you? Exactly. You put the last digit here in carry, if you need to. And then the algorithm says you add the tens column together. 6 plus 5 is 11, plus 1 is 12. Same thing, if it's above 9, you have to carry stuff. And then the last thing is do the hundreds column, 4 plus 1, and you get 520. And that would be the algorithm that you use for it. And you will, on a quiz, I will ask you what is an algorithm, and all you have to do is write this down the way you do something. So like when your parents ask you to do a new job, let's say your parents ask you to sweep the floor, you should say, you have to give me an algorithm for that. Or like they say, why don't you put air in your bike tire? And you go, hey, I need an algorithm for that because I have no idea what I'm supposed to do. Anything where you need directions, use the word algorithm, and they'll just kind of help you out, and then you'll sound real mathematical. Doesn't that sound fun?